Hello, today we are going to discuss about concentrations based on volume. This is most widely used concentration format in biochemistry laboratory. This video is for those who are new to biochemical calculations or who wants to brush up on the biochemical calculations. That's being said, let's start. There are many forms of concentrations. Out of those forms, we are going to discuss about molarity only today. So this is multi-part video series about concentrations based on volume, and in this part we will talk only about molarity. We will discuss this topic in slow and deliberate manner. So sit back, relax, and let's start. Before we dive into the various forms of concentrations, or before we talk about the molarity, let's discuss about solvent, solute, and solution. So if I take one beaker, I add some water, some water has been taken, and we are going to add some sodium chloride, that is our common salt that we will use in our daily life. So these red dots are the dissolved sodium chloride. This dissolved sodium chloride is our solute. This is water, and this water will become our solvent. Once solvent and solutes are mixed up together, this whole thing is known as solution. So never confuse between this solvent, solute, and solution. These three are really confusing word, but we need to clear it before we discuss about any forms of concentration. Now let us move to the molarity. What is molarity? So the molarity is the number of moles of solute per liter of solution. So moles of solute per liter of solution. So if we say that I have 5 moles of NaCl in 2 liter water, sorry, 2 liter of solution, because if I take water, 2 liter of water, then it will become a solvent. Okay, we need a volume of solution, not the solvent. So here 5 moles per 2 liters. So obviously in 1 liter there will be 2.5 moles. So I can say 2.5 mole per liter. So this become our molarity. Whenever we want to mention about molarity, we can always use the square bracket. Whenever something is written in such type of square bracket, it automatically tells us that we are discussing about molarity. For example, for this example, I can simply write that for this solution, square bracket NaCl is 2.5 m. So reader will understand that we are talking about molarity, and that is mole per liter. So that is 2.5 moles per liter. Now we discuss the definition. One question arises that what is mole? Why we are preferring it? So mole is very simple word, but before that, let us look at this word dozen. If I say 1 dozen of orange, that means one will understand that I am talking about 12 number of orange. If I say one score of orange, that means 20 oranges. One gross, that is 144 oranges. Myriad, that is 10,000. So these all words are used in common language to denote some number. So similarly, mole is used in any scientific terminology, and it denotes some number. That number is 6.023 into 10 raised to 23. This specific this particular number is known as 1 mole, and this number is also known as Avogadro's number. So for example, if I say 1 mole of sodium ions, that means 6.023 into 10 raised to 23 numbers of sodium that we are talking about, and 1 mole of H2O means 6.023 into 10 raised to 23 number of H2O. So the specific numbers of particular ion or molecule or atom or electron. If I say 1 mole of proton, that means I am talking about this much, this 6.023 into 10 raised to 23 numbers of protons. So this must be clear. But there is one problem, that how we will able to count this much number of molecule, and even if we determine to count, we must see it. But obviously we cannot see such a small molecules. Not even a single instrument in all over the world is there which can visualize a single atom or single molecules. So what is other way around? The other way around is use of molecular weight. See, what does molecular weight tells us? Molecular weight tells us the weight of 1 mole of any atoms or molecules or ions. So if I say this sodium chloride molecular weight is 58.44 gram per mole. That means if I take 58.44 grams of sodium chloride, that means I am taking 1 mole of sodium chloride. And by 1 mole, I mean to say 6.023 into 10 raised to 23. Okay, so in simple words, this much number of sodium chloride, its weight will be 58.44 gram. So if I want to take like 6,000 atoms, then I can simply cross multiply this 6,000 into 58.44 divided by 6.023 into 10 raised to 23. So this answer will be in the gram, and that much gram, if you weight out that much amount, that much quantity of sodium chloride, then you will get this much number of sodium chloride. Okay, so molecular weight of NaCl is 58.44 grams per mole. This number, this molecular weight, you can see it on the standard packing. This is sodium chloride packing. AR stands for analytic grade reagent, which is highly purified. Okay, so if you want to take 1 mole of NaCl, we'll take 58.44 grams of NaCl. Okay, if you weight out this much this much of NaCl, you will get a 1 mole of sodium chloride. Now if you want to find out that how much moles are there in 100 gram of NaCl. To do that, we can simply say that if I take 58.44 gram of NaCl, then there is 1 mole. So if I take 100 gram of NaCl, then how much mole? So for that we can cross multiply it. So 100 gram into 1 mole divided by 58.44 gram. So gram out. If you do 100 by 58.44, your answer will be 1.71. So this unit will be mole. So if you take 100 gram, then your answer will be 1.71 mole. So what we had done is, here we wanted to find out the moles. So we had taken the weight in gram divided by its molecular weight. See, this 100 was our weight and this was our molecular weight, this gram per mole. So this this division will give us a number of moles. So we can simply apply this formula, that is moles is equal to weight in gram divided by molecular weight, whenever we want to interconvert between moles and weight in gram. Now, so we learned two things. One is formula for molarity. That molarity is the number of moles per liter of solution. So it's a moles by liter, and for the moles and weight in a gram, if you want to interconvert, this formula will be useful. Now example 1.1, that what is the molarity of solution prepared by dissolving 16 gram of sodium chloride in enough water to make a total 1000 ml of solution. See, in this molecular weight of NaCl is given, that is 58.44 gram per mole. So here what we will do is, first step will be find out moles of NaCl. Okay, first step will be find out moles of NaCl, and then the second step will be, see, in the first step the 16 gram is given, but gram is not useful for us. We need to convert it into the moles because molarity is moles per liter. And our second step will be, once we had found out mole, we will apply molarity equation. Okay, let us carry out first step. So we all know that moles is equal to weight in gram divided by molecular weight. So here weight is 16 gram. Better to write unit with any number, so calculation will be easy. 58.44 gram per mole. Now gram is out. This mole will be in the upper side, so this will make 0.27 moles. So what we had here done is, simply we had converted this 16 gram into mole. So whether you say 16 gram of sodium chloride or you can say 0.27 moles of NaCl, both are same thing. Now once we had converted this into the moles, we'll find out the molarity and apply the molarity equation. So molarity is equal to moles per liter of solution. Now we have 0.27 moles, 0.27 moles divided by 1000 ml. Now we want a liter as a unit, so 1000 ml is equal to 1 liter. So we'll write down 1 liter. So now we have 0.27 moles per liter. So this is our answer, and if you want to write down this answer in a proper manner, then we can say that molarity of above solution is, or you can simply put down square bracket, is equal to 0.27 m. Capital M, that means we are talking about moles per liter. Let us move to the second example, or example 1.2. Now here the question is, what is the molarity of solution prepared by dissolving 23 grams of KCl, that is potassium chloride, in enough water to make a total 550 ml of solution. Here molecular weight of KCl is given as 74.55 grams per mole. So here our steps remain same, that first find out moles of KCl, and our second step is apply molarity formula. So first let us try to find out 23 grams of KCl is equal to how many moles of KCl. So we all know moles formula, moles is equal to weight in gram divided by molecular weight. So here weight is 23 gram divided by 74.55 gram per mole. There is point, okay. gram out, so mole will be on the upper side. So 0.308 moles. So 23 gram of KCl is equal to 0.308 moles. Okay, now we can apply molarity formula. So molarity is equal to moles per liter. Now here there is one glitch. Okay, so moles we know that it is 0.308, but liter 550 ml. So 550 ml, if I divide it by the 1, but instead of 1, if I say 1 liter, 1 liter divided by 1000 ml, see, the answer of this is 1, because both are 1 liter divided by 1 liter. So we are just converting this into the liter. So here ml out, so 0.550 liter. We can use this liter unit over here, so 0.550 liter, and this makes our answer as a 0.56 moles per liter. So we can simply write as a KCl is equal to 0.56. This is our answer. For all practical purpose for making the different kinds of solution in laboratory, you can always apply this logic. Now let us try to find out this example 1.3's answer by yourself. If you want to try it out, pause the video right now and you can carry out. I had already given the answer and you check your answer with this. Now it's the time to pause the video. Okay, hope your answer is correct, and for those answer was not correct, let us stay with me. Okay, now what is the molarity of solution prepared by dissolving 23 gram of NaOH, that is sodium hydroxide, in enough water to make a total of 170 ml of solution? The molecular weight of NaOH is 39.997 gram per mole. Okay, here our step 1 is find out moles of NaCl. Find out moles of NaOH, and second, apply molarity formula. Okay, so moles is equal to weight in gram divided by molecular weight. Our weight is 23 gram divided by molecular weight is a 39.997 gram per mole, gram out, so answer is 0.575 moles. Now we can apply molarity formula. Molarity is equal to moles per liter, so our moles is 0.575. Okay, and our liter is 170 ml is equal to 0.170 liter. This is moles and this is the below is liter. So the calculation will give you answer of 3.38 moles per liter. Now this one more and last example, example 1.4. This also you can carry out. I had already included the answer. You can check it. Now it's the time to pause the video. Okay. I hope your answer is correct, but if it is not, then stay with me. How many grams of solid NaOH are required to prepare 700 ml of 0.06 molar solution? Now see, this is reversed. Okay, suppose in some lab work you are supposed to prepare 700 ml of 0.06 molar solution. So how will you prepare it? How many grams of solid NaOH are required? So first what we can do is we know the volume of solution and we know what molarity of solution we want. So from these two, this molarity and this volume, from these two things we can find out moles of NaOH which is required, and we can always convert moles to the gram, right? So this is just a reverse situation. So based on these two, let us first find out how many moles of NaOH are required. So for that we have this equation, that is molarity is equal to moles per liter. Okay, now we know the molarity, that is 0.06. The moles that we want to find out, the liter is the 700 ml, so 0.7 liter. So now if we rearrange this, the moles will be 0.06 into 0.7, and this will make a 0.042 moles. So this many moles, 0.042 moles of NaOH is required to prepare this characteristic solution. But we have to convert these moles into weight. So to convert it into weight, we have one formula, that is moles is equal to weight in gram divided by molecular weight. So moles is 0.042 is equal to weight that we want to find out divided by molecular weight, that is our 39.997. If we rearrange this, so weight in gram is equal to 0.042 multiplied by 39.997. If you do the multiplication, your answer will be 1.68 and the unit will be in the gram, right? So if you take 1.68 gram of NaOH, go on adding go on adding water, and if you make a volume up to 700 ml, then your solution's molarity will be 0.06 molar solution. I hope you understood this. So thank you. If you have any queries or suggestion, please write it in comment section. I will definitely try to address it. Please like, share and subscribe to channel. This will encourage me to make more such videos. Thank you. Our next topic will be on the normality. Thank you.